right, here we go. I hate to do this because it might mess it up, but I'm going to try it. Okay, it says that there's a comedian, he's building a fan base. So this table shows the number of people who attended his shows the first, second, third month of his career, and so on, fourth, whatever. Which graph represents the table? So you have to think of spacing here. One thing, are we going up in the fan base or is it going down? From here to here to here to here. Is it going up or down? Up. So you're going to look, let me move this. What graphs are going up? Can y'all tell which ones are going up and down? Yeah, A and D are going up. How do you know? Watch. You read from left to right, y'all. Okay? So as you read this graph, this one's slowly going up. This one is going down. This one is going down. And this one is going up. It looks like the same amount every time, doesn't it? This one looks like it just goes up a little more, and then more than that, like it's increasing right every time. What numbers match that? So if you need to, just subtract. Does it look like we're going up the same amount every time? No. It looks like it starts off small, but then it's more, and then it's even more. What graph was that again? A. Does everybody understand that? So you're just looking at, first of all, is it going up? And second of all, like, what are the distances that it increases? Okay, that one was A. Looks like a lot of pages, but the graphs just take a lot. This one is about a hiker. We've already done this question. You're trying to find the graph that matches this little scenario. A hiker climbs up a steep bank, then he rests, then he walks up a small hill, and then finally across a flat plateau. If you don't know what a plateau is, at least it says it's flat. Okay? What graph represents his elevation? Elevation is how high he is. So what does it start with? At first, he climbs up something steep. Well, don't all three of these graphs look like it's steep at first? Okay. Then when he takes a break, is he going up any? No. So it's going to be a little flat surface. That says that he quit for the day, it looks like. Doesn't it? It doesn't change any after that. So we don't think it's this one. All right. Both of these have a small flat surface where he didn't go anymore. Then it says he walks up a small hill. That looks like a small hill. That looks like it's a little steeper, but they both could represent the small hill. But then what's the last thing? A flat plateau. Which one of those looks like it's flat? A. So it's A. Does everybody understand that? You just go step by step through the graph. Okay? So steep hill, takes a break, small hill, flat plateau that he walks across. His elevation didn't change. All right, then we have one of these. Yay. This one has several questions that follow it. It looks like it's question 3, 4, 5. Yeah. All right, so this one goes with 3 questions. I don't know if y'all can see this, but this is a 5 by 5. It says it's a rectangle, but it's really square. All right, so when there is one rectangle, what's the perimeter all the way around it? Well, let's look. 5, 10, 15, 20. Does everybody understand where I got 20? So one rectangle should go with 20. All right, I see some answer choices that match, don't I? Okay, for 2 rectangles, what's the perimeter? 5, 10, 15, 20, 25, 30. So which one's our answer?
B.
B. All right, here's our table that matches the perimeter. All right, now the next question, it's our graph. Let me just put the graph right here. What graph matches this table? So I'm still going by what I just found. I would go over 1 and up 20, over 2 and up 30, over 3 and up 40. So let's do that. Let's see if we can find over 1 and up 20. So it looks like it's one of these, doesn't it? Because see, this one goes up to, I don't know, like 10 or 12. This one goes up to like 40. But I said we got to go over 1 and up 20. What was the next number? Over 2 and up 30. So this one is at 230. This one's at 235. So which one's the answer? B. Do y'all understand what I'm doing here? I'm just matching the table. Then if I went over 3, I should be up at 40. So this is the one that's matching. Okay. Then this next one says, let's start with the equation and then we can use words. So you can go back to this part if you want, but I'm going to do words and an equation. Actually, I really like the table. I think the table is the easiest one. Let me go backwards. If I had no rectangles, it would be 40, 30, 20. What number would go here? 10. So now I'm ready to write my equation. What am I going up by every time? 10. So y equals 10x. And what do I start at right here at 0? 10. That's your equation. That's probably the easiest, to me, that's the easiest way to do it, to look at your table. But your table has to start at 0 to do that. So I just found it. Does that make sense, y'all? Maybe not. Here, I'll show you the other way. Let me erase that. Let's look at this. Right here, our little rectangles. Okay, what's it going up by? So from here, I had 10, and then what did I add to this 10 right here? What did I add right here? 10 more. Every time I increase the rectangle, it's going up by 10. That's where this number comes in. Okay, what's on the outside? 5 and 5 is 10. That's where that number comes. That's a way to look at the picture and tell. This number right here that I underlined, that's how much it goes up by every time. Okay? That's the number that's on the outside if you look at the picture. We're about to do another one. Then in words, I could just say let's see. The perimeter is 10 times the number of rectangles plus 10. That's what it basically says. The perimeter, because that's what this is about. Where's the number of rectangles in the perimeter? The perimeter is the number of rectangles times 10 plus 10. That's it. Or if you put y equals 10 times x plus 10, I would take that as well. That is words for your equation. Okay, keep it simple if you need to. All right. Let's do another one of these. Okay, only one of these would be on the quiz. So that was the first one. 3 problems that go with it. Let's do one with triangles. Okay, but let's just start with our equation. Okay, let's skip all this. And notice they use P for perimeter. Let's skip all the words. What's the perimeter? Or I'll use y equals. What am I adding every time? I'm only adding one side of a triangle, which is what? What am I adding to it every time? Can y'all tell? 5. So it's 5x. And what are the numbers at the end that stay the same every time? 7 and 7. What is 7 and 7? 14. There you go. So there's your perimeter. Perimeter equals, and see they use different letters, 5n plus 14. So it looks like it's, which one matches? Perimeter equals 5n plus 14? No. Perimeter equals 5n plus 14? No. That one right there. That one doesn't match. So see, all those words, I didn't even have to read a word, did I? The perimeter, that's all I had to find. Y equals 5x plus 14, or use their letters. Does that make sense, y'all? Is it getting better? Okay. I think we're about to do a table, so if you wanted to find the equation with the table in a second, we can. So, actually, this one just says, what were we adding to each time? What did we say we were adding each time? 5. So that's C. You add 5 to the perimeter each time. Okay, that's just what, right here, 5, 5, 5. Every time we're adding a side with 5. So 7 is C. Now, number 8 is our table. So I'm going to move this. The table looks like this. Number of triangles, and then the perimeter. I'm just going to write it here. One triangle, what's the perimeter of that one triangle? Is it 19? Yeah. Okay. What is the perimeter of 2 triangles? 7 plus 5 plus 7 plus 5. 24. And then 3 triangles is 29. What did we say we're doing every time? What are we doing between every number? Going up by 5. Adding 5 every time. That's where that 5n came from. Plus, and then you could go backwards to 0. If you subtracted 5, it would be plus 14. That's another way to think of it. Okay? So 5n plus 14. That was one of the answers for your table. This is what their table looked like. I just couldn't fit it all on the screen. We just would have written those 3 answers there. Oh, I'm betting this is a graph and I already erased it. I'll just try to remember. Okay, so here's the graph of the same problem. So let me do that. One triangle was 19, I think. So I would go over 1 and up to 19. Are we okay with that? 2 triangles was 24. And then 3 triangles was 29. There we go. That's our... We could keep going if we wanted. You can see the pattern.
Well, what's the word where it goes up, side, over, down?
Linear.
Okay.
Yeah. And it's a linear equation, which that's all the whole next chapter, I believe. Okay. Then it says, I don't think we do number 10. Just skip number 10 because I think that's just asking for the equation again. It was like that on the worksheet. It just wants the equation. We already wrote it. Okay, number 11. Describe this situation. Same exact problem we had on the worksheet. Lena's making deliveries for the grocery store. She only stops at traffic lights and homes where she makes the deliveries. Okay? The graph shows her distance from the store on her first trip of the day. What are the variables? First question. People miss this one. It's right there. It says, what are the variables? What are the 2 variables? They're written on the graph. They are the variables, but what words do they use for them? That is your variables, X and Y.
Distance and time.
Distance and time. That's what it's going to want. Your variables are going to be distance and time. Time is your X variable. Distance is your Y variable. Okay? Now, describe how they are related at various points. Do y'all want me to write it every step of the way, or do y'all want me to number them? What way did y'all like? Anybody? I think they're watching something. You want me to just number them? Okay, I'll number them. 1, 2, 3, 4, 5, 6, 7, 8, and 9. What's happening at 1, 3, and 5? Because that's all the same thing happening. What's happening at 1, 3, and 5? Going where though? The graph is going up, but look at it from the perspective of our problem. Where's she driving?
To make deliver the groceries.
Yeah, so she's heading away from the grocery store. Her distance away from the grocery store. So 1, 3, and 5 headed away from grocery store, or away from store towards home, or delivery home. Does that make sense, y'all? She is headed away from the grocery store. That takes care of 1, 3, and 5. All right. What's happening at 2, 4, and 8? Because those are all little small stops. What's happening at 2, 4, and 8?
Red lights.
Yeah, traffic lights. 2, 4, and 8 stopped at traffic lights. Stopped at traffic light. Why is there only 1 on the way back? It could be 2 things. She took a different route, or she caught a green light. Does that make sense? Anyway, that's why. Because here, why did she have to stop twice? But here, she only had to stop once. Maybe this one, she just caught the green light and kept going, or she could have gone a different way back to the grocery store. Okay, so I've done 1, 2, 3, 4, 5. What's happening at 6?
She making the delivery.
Yeah, making the delivery. Making delivery. Some people would even write this like as a little story. You can write it as a story or write on your graph. Then the last thing I have is 7 and 9. What's happening at 7 and 9?
Going back to this one.
On her way back. That's right. She's on her way back. There we go. I think that one's on there. I'll tell you in a little bit which ones are for sure on there. Are we good with this? Yes. Okay. So, I don't care how you write them. Just don't forget distance and time. All right. Let's see what's next. Keep moving along. This is what you were asking, linear or not linear? Is number 12 linear or not linear? And I'll tell you why in a second.
Not linear?
Let's see. What made you think that?
But they're not going over evenly?
Did you check them to see? So you're going to want to check it. How do you check to see? Just subtract them. Just subtract the bigger number minus the smaller number. So like me, because always make sure, I would do like, what is 21.4 minus 12.7? Okay, that's 8.7. Let's check 30.1 minus 21.4. Oh, also 8.7, but let's check them all. 38.8 minus 30.1, and then 47.5 minus 38.8. So is that linear? Yes, that one's linear because they're going up. It's like steps, the same exact amount. It's going to make a straight line. All right, this one, let's subtract this one. And just in case, we'll do, and it doesn't really matter where you start. We'll start the same way. 0.09 minus 0.3. Now, 0.03 minus 0.09. Okay, are these the same numbers? No, then they're not linear. And y'all, if you started with the first number minus the second number, that's fine. Just keep doing that every time. Does that make sense? Really doesn't matter if you start with the first one or not. I mean, if you start with the bigger one or not. Okay, so that one's not linear. All right, then there could be, I can't remember. We'll practice these. I can't remember if these are on there. Possibly, but it says which one of these functions fits these ordered pairs? Which one could represent these? So what do? You plug and play. All right, let's try it out. Let's plug in 1, 1 into this equation and see if it works. So like if I plug in x is 1, do I get 1? All right, so let's plug it in right here. What is 1 plus 2? 3. Did that one work? I wanted to get 1 as my answer. No. Let's plug in 1 for this one. What is 1 squared? 1. If you're not sure, y'all, check it. 1 squared. I did get 1. Now guess what we need to do? We need to just check a few more. What is 2 squared if I plug in 2? 4. What did I want for my answer? 4. What is 3 squared? 9. What is 4 squared? 16. Do y'all see why B is your answer? It worked. Okay, so B is the answer. Let's do another one. Okay, let's plug in 1 again and see if we get 49. What is 1 to the 6th power? How do you do that on your calculator? There's this little up arrow right here to the, I call it the button. It's an arrow. 6. And it's 1. So if I plugged in 1, did I get 49? I did not. Very far from it. Okay, let's try this one. 6 to the x. 6 to the 1. 6 to the 1. And I get 6. So that one's not going to work. I needed 49. Let's plug in 1 here. What's 1 plus 6 squared? So look, I'm going to do this. I'm just going to put parentheses. And I'm going to plug in 1 plus 6 close parentheses, squared. Does everybody see how I did that? I just wrote exactly what they did, but I plugged in 1. Do I get 49? I'm pretty sure that's going to be my answer. Does everybody understand that? It's plug and play. Just plug in the x value, see if it spits out the right y value. Okay, do we need one more? Or are y'all good with that? You're good. Okay, let's see. Number 17, we've only got 2 left. And then I'll tell y'all what ones are on there. Number 17 says, what is the graph of the function rule? So on this one, how do you graph these? Hey, the easiest way, guess what I can do with my little calculator? Let's just go to y equals. What does this say right here? That says negative x minus 3. So what do I type in? Negative x minus 3. And which one looks like it matches?
D.
D. Okay, let's say we don't do that. You don't have to do that. You're really not supposed to know that yet. But remember, we'll just pick some numbers for x. What 3 numbers? I like to pick small numbers. 0, 1, and 2. And plug them in. What is 0 minus 3? Negative 3. Because there is no negative. I couldn't put negative 0. What is negative? And I'll plug in 1 minus 3. That's negative 4. And let me plug in my last one. It has a negative sign. 2, I'm going to plug in 2, minus 3 is negative 5. And if I plot those 3 points, like let me just start here. Over 0, down 3. Did that one work? That one's not on the graph. Did that one work? That one's not on the graph. Over 0, down 3. Hey, that one worked. So let's try my next one. What does it say? Over 1 and down 4. That's right here. Is that one on the graph? No. D matches. Okay, that's how you just plug them in. Okay. I hope y'all feel good about this quiz. I hope it's like, I don't know, that you're just getting it. This last one, the little word problem, it says it gives you this little equation, and it says the cost, or a taxi company charges passengers $1.75 plus an additional 25 cents for each mile traveled. Here's your function rule. All right, it says you've got miles for M and cost for C. If it only goes up to 40 miles, what's a graph of the function? So what can your M values go to? What did we just say? Your M values can go up to 40. Does everybody see that? So if you just got in the car and you drove, what does it start at? 0 miles. What does it automatically cost you? If you plug in 0. 0.25. I'm just plugging it into my equation. 0.25 times 0 plus 1.75. If I don't even go anywhere, it costs $1.75. So that looks like either of these graphs, doesn't it? If I plug in 0, this one doesn't even have anything. Okay, so it's one of these. Now, if I plug in, what's the next number that they have? What are they counting by? It has 0, space, 10, space, 20. What's on those spaces? 5s. 5, 10, 15, 20. Okay, we'll just skip to 10. Let's plug in 10 and see what answer it is. It's going to be, I guess, $4. 0.25 times 10 plus 1.75. And it's $4.25. Both of those match. Okay, so the difference, all these numbers match. What is this graph saying? Does it stop at 40? Or it keeps going? And this told me it can only go up to what? 40 miles. So it has to be C. That's the difference. Does everybody understand this? So it's just which graph kind of matches. You just have to know how to read it. You can go anywhere from 0 to 40 miles. This is the graph that's showing. It starts at 0, stops at 40. Okay, that's what you're looking for. You didn't even have to plug in the numbers. Okay, now which ones are on there? I know you're ready to know. And if you want another review, I can get you another review. That says practice quiz. So, let me see. Is this the same practice quiz? Oh no, it's a different one, so I can tell you which one's on there. Okay, so there's one, this was the first one that I did. There's one like this, where you just have to tell which graph. So I'll make a copy of that one. Then the next one on there is the hiker. Okay, so I'm gonna make a copy with the hiker one on there. Then the next one is the rectangle. So it's got the rectangle with the perimeter, the graph, and the words. All right, so then it had the rectangles, the graphs, and the words. Then I have, gosh, how many problems are on here? Okay, it's almost done, I think, maybe. Let me see. I think I'm gonna have to make a different one. Yeah, because it's not matching. Let me just make one real quick. I'm gonna pause that video while I make this. I'm making it as I go through. So there is one like this. I already told y'all that. Then there's one like the hiker. I'm going to leave that one on. Then I've got the rectangles, which includes the graph and the equation. And the equation. Okay, I'm taking the triangle ones off. Because there's no need in having two of those on there. Okay. So the triangle ones are off of there. Then I have not that. Oh, I will have, oh, this practice quiz was different. Or did I skip something? Here they are. That's what I skipped. I will have linear or not linear. I'll do one of those. And I think I'll have one where you plug in the numbers. So one of these. Okay? One of these will be on there. There we go. And the graph one, that's going to be this one right here. I'm going to get there. Where you graph it. Let me see what else. I think I'm at 10 questions. I didn't put that one on there. Okay, so that puts us at 10 questions. That's what we're going to have on there. So I'm about to do a practice. Let me print these. Change. All right, let me print from two-sided. How many? 1, 2, 3, 4. 1, 2, 3. I'll do 4. Okay. And I'll go grab those really quick.